I am now going to demonstrate you how to use our IDL visualization tool. And so first for that, I will go to our wiki website and find the place where we have the tutorial for working with this tool. Alright, so if you just go, let's go to the wiki page for the short course for the full 2013. Here we go. And there we'll just follow in the program. We'll go down in the program, and we go in the afternoon, where there is the basic tutorials for reading and plotting data. And so there's some basic information first on how you should install IDL, and so I will recommend you to follow these instructions. And in particular, you can go to the page here, Reading and Plotting Spectral Data with IDL, which gives further detail if you haven't installed IDL and what you do about it. So once you have it installed, alright, let's say we have it in our directory called tools/IDL. I'll just start IDL. This is because I have a license. Otherwise, you have to use IDL-RT equal blah 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 blah. Okay, and I'll just start my visualization tool. So here the way it looks. All right, here we have the instructions, and we'll just follow that. So first, what we want to do is to select some data. So we're just gonna go to this drop list here and look for the model time series here, and here I'm going to go down into my archive where I have all the stuff necessary here. So it's going to be in there, and this is this file here, spec.nc file. If you haven't got it on your hard drive yet, just download it from my FTP site. You can follow the link from the wiki page here, model spectra taken from the FTP. And then once you have loaded the data, what you can do is just to select what you want in the time series drop list with model data. Then you will see that you have the variable name that appears here. So E with a parenthesis here means it's a directional wave spectrum. So just select that. And boom, what happens is we get a time series of what is actually the wave heights, which were recomputed on the fly from the wave frequency and directional spectrum. Now, if we want to change data to be displayed, and we actually want to watch and look at this directional spectrum, so we have to change the processing type. So here it was selected the TS bulk for the bulk time series. And if you go down and instead select the F theta spec, so it's a frequency directional spectrum, and then just click on refresh, you will get this plot, which looks a bit funny, but then you can change the plot type to make it look nicer, and it's explained here. And for example, you're going to use the polar poly. There you go. So you have this small blob of energy here on the center of the diagram, and you can zoom in with the frequencies to only, okay, here you see only the frequencies up to number 16, which is about 0.15 Hertz. So this axis from the center to the outside is a frequency axis in Hertz, and the directions that are plotted are directions from which the wave are coming. So here you have this red thing here, which is the maximum of the spectrum. It's the peak of the 2D spectrum, which is at a frequency of about 0.007, which is a period of around 14 seconds, and a direction coming from an azimuth about that's 270, and then because there's 24 directions, 15-degree resolution, so this direction here is like 255. Now you can see there's a summary of wave parameters shown here that give you the significant wave height, the peak frequency, mean direction at the peak, and so because it's a mean, it's actually an average over all the energies at that frequency. If you change the frequencies, you will see that the numbers change, and so if you chop off the high frequencies, only keep the low frequencies, you'll see the wave height is now down to 1.77 meters. And if you go back to the full spectrum, it's going to be back up to 2.27 meters. Now what you see is there's also an arrow, black arrow here, which corresponds to the wind direction. If you had read a file which was also a current used in the calculation, you would also have another arrow for the current, but it's not shown here. So the wind speed is written up here, so it's 6.96 meter per second, and the current speed here is 0. So wind is coming from the southeast, and we'll get some waves going in the opposite direction. And actually, there is a bit of energy coming from the south. You can barely see it, and this is a matter with the colors. You could actually enhance these colors if you now open the toolbox plot parameters, and instead of a linear scale on top here, you lose a log4 scale. Yeah, well, not much change here. Maybe that's alright. But we see some kind of gray thing, or the other option is to fix the maximum here. So instead of going all the way to 18, we say, okay, I'm going to crop the values up to 9, and I'm going to go back to the linear scale here because I don't know what's going on. Alright, so it's maximum of 1. Alright. And what if we do 0.1 in the maximum? Okay, so I put here in the min max 0 and 0.1, and if I put a lower value, then it will naturally enhance. Essentially, it will put a maximum value of 0.1, and it will just blow up all the other things. And now you can see that at higher frequencies, yes, we do have waves going in the wind direction, which is coming from the southeast and propagating towards the northwest, following the arrow. But in that case, these very high waves are much smaller than the swell, which is these other waves coming in opposite to the wind at a longer period. So that was playing a bit with just plotting this. Now some people don't like too much this kind of blocky look of the plot, so you can also go to a contour thing. Here again, I'm going to zoom in on this, and this is the kind of plot you get. And then with that plot, well, you can still play a bit more. Let's see what I had on my wiki page. Yeah, if you want to, so here I put the max at 1, I could actually put back the original maximum value. Oops, there, what's going on? Up to 10, 20, so the original maximum value was 100. Okay, and now the color scales goes from 0 to 18.26, which, yeah, you know, these are funny numbers. So if you prefer to have it on round numbers, maybe you can chop it up at 15. All right, and now you want to change the tick marks on this axis. You just open the plot parameters toolbox here, and then you can change here the number of contours. So we can make it say 31. All right, and here you get more contours with more values. And if you want more tick marks on the bottom of this box here, you can change this number of ticks from 5, say, to 15. Okay. So the number of contours is always one larger than what you have between the min and the max. It's because it allows for the color for the higher values, which is here beyond 15. Now we're happy with our plot, and we may want to save it as EPS or PNG. So if you want to save it as a PNG file, which is a raster format, you can just go here to the output, save as PNG, and it will just propose some names. Okay, my plot.png. Oops, no, sorry. You have to put the name on the bottom. So here, my plot.png. Here we go. Now, if you save it as an EPS without doing anything special, it's going to look ugly because you have a white background. So I can show you in another. Let's open. So we use Ocular to visualize this EPS plot. and you see the stuff is written in white with white background. So if you want to avoid this, you have to change the palette. And so you can, in this read file drop list here, you can read in a different color palette. And for example, the one which is the same as this one but with a black background, which is going to be good for EPS, is this. And now if you save it as EPS, and we call it myplot.eps. Okay, now you're going to have this nice looking plot that you can stick in your next publication. Alright, so that was for basic plotting and reading. We can also now play a bit with the time. If you play with the time arrow, so you can slide the slider here with the mouse, or you can also use the arrows left and right to do it temp step by time step. And now you can, let's go back to more frequencies. Now you can see, the wind turning and the spectrum responding to it. At some point the wind dies. Okay. And now you see another wind sea coming in this direction, and you still have the swell coming from the west. So this is a very nice way of understanding what's going on in terms of spectrum, because okay, now you see this wind sea developing. The wind is like 10 meters per second, and now it's still stable, 10 meters per second, and now dying a bit to 6 meters per second, and so we only have swell now, and so forth. And now another wind sea coming from the southwest. So it's kind of nice looking, so you can play with that. Enjoy!